right, students, today we're going to look at the idea of solving combined inequalities. These combined inequalities can also be called compound inequalities. And we're going to see that there are two different types of compound inequalities. Okay, type number one is called conjunctions. And we're going to see conjunctions can be connected by the word and. Right? So it's a conjunction is two inequalities that are sentences joined by the word and. Now, to solve a conjunction, you find the variables of the values of the variables for which both equalities are true. So what we're trying to do here is we want to find the answer. We want to know what is common to both. Now, what we're going to see is that's going to show us an overlap as we graph. So let's go ahead and look at the first equation here, and let's graph this. Now, if you remember from last week, we said that to graph an inequality correctly, the letter needs to be in front. So we need to switch this around. But remember, when I switch the order, I also have to switch the sign. So the first inequality that we need to graph is x is greater than negative 3. Well, we're going to go down here to negative 3, and we're going to put an open dot. Remember, because that is greater than, we don't include negative 3. And then we're going to go over here to where x is less than 5. So we're going to go to where x is less than 5, and we're going to put an open dot. Now, this inequality is going to go this way, and then when we get to the x is less than 5, I'll use a different color, and this inequality is going to go this way. And remember, if it's an and, we only want the part that's common to both. We want where those graphs overlap. Now, some of my students have said it's a collision. Some of my students said, oh, Mrs. Burton, that looks like a bus. But whenever we get done graphing a conjunction, we're going to get a line segment. Okay, we're going to get a line segment as we go through. So the answer would be the green line. Okay, or we could just put the connection between the two, and we'll see some more of those as we go. Now, I want us to look especially at problem number 2 here. So when I go to graph that, when I look at that, well, we need to graph t is less than 5. Well, if t is less than 5, we're going to put an open dot at 5. And remember, my inequality is the tip of my arrow, so it's going that way. To graph t is greater than or equal to 6, I'm going to go to 6 and put a closed dot. Remember, because of that equal to time, we include it. Now listen, this is an and, this is a conjunction, and if you look there, there's nothing common to both. There's no overlap. So for this equation, our answer would be the empty set. So that's an important thing to realize. Now, not only are they going to have us graph these compound inequalities, we're also going to have to solve. And you notice our new battle cry is going to be solve and then graph. So if you look at number 3, this is our shortcut way to write a conjunction. Sometimes a conjunction says and, but most of the time they're going to write it in this form. This is my shortcut form for a conjunction. Now, if you notice, I need to get m alone. And to get m alone, I've got to get rid of my floater. We've got to subtract 1. Now, because it's a compound inequality, because it's a conjunction, if you notice, I got a front, a middle, and a back. So whatever I do in the middle, I have to do on both sides as well. So if I'm going to subtract 1 here, then I also have to subtract 1 in the front and in the back. So let's go ahead and see what happens. We've got negative 3 is less than m is less than equal to, and 4 and negative 1 is 3. Okay, so we've solved our inequality. We got m alone. Now this means that m has to be greater than negative 3, and m has to be less than or equal to 3. So how do we graph that? Well, we're going to go down here to negative 3, and we're going to put an open dot, and we're going this way. And then we're going to go over here to m is positive 3, and we're going to put a closed dot, and this m's going this way, and we keep going until they collide. All right, and so there's my line segment, there's my bus. So when I graph a conjunction, when I graph an and, my graph should look like a line segment or a bus. And here's how they got bus. The wheels on the bus go round and round. So the open dots and the closed dots are the wheels. Let's try another one of those. Let's go here and look at this equation. Once again, it's a conjunction. It doesn't say and, but they wrote it in the shortcut method. And so we still need to isolate the variable by inverse operations. So if you notice, I need to get x alone, so we need to get rid of the 1 first. So we're going to use our opposite or inverse operation. So we're going to add 1 front, middle, back. We've got negative 6 is less than negative 3x is less than equal to 9. Now, do you notice we still don't have x by itself? We're going to have to divide everything by negative 3. Oh, did you hear what we're dividing by? We're dividing by a negative number. So remember, that means that I need to flip my inequality sign. That's important. And then we've got x, and here we divided by a negative number again. So there it is. So that rule, to flip or not to flip, still holds true in this chapter, no matter what section we're in. So this means x is greater than 2, and x is less than equal to negative 3. So how would we graph that? Well, if x is less than 2, we're going to go down here to positive 2, open dot, and our inequality is going this way. And then x is less than or equal to negative 3, closed dot. And if it's greater than, we're going to the right, and we connect where they collide, where they overlap, and there's my bus. Okay, so if we're doing conjunction, sometimes they say and. Most of the time they don't. They write it in the shortcut method. We solve, and then we graph, and our graph should be a line segment. Now, the second type of compound inequalities are called disjunctions. And the key word on a disjunction is or. Now, here's how you can tell them apart. A disjunction always says or. So as soon as you see or, then we know it's got to be a disjunction. Now, to solve a disjunction of two inequalities, you find the values of the variables for at least one of the inequalities is true. So when we're solving these disjunctions, we're going to see that we want all possible answers. All possible answers. Okay, so let's look here at number 5. And if I'm going to go ahead and, first of all, I need to get x alone. So I'm going to have to subtract 3 to the other side. So we're going to have negative 2x is greater than 4. And then we're going to have to divide both sides by negative 2. And so we're going to get x, flip the sign, negative 2. Okay? Or x is greater than equal to 1. So how are we going to graph that? Well, we're going to go to x is less than negative 2. We're going to put an open dot, and we're going to go to the left. I'm going to graph underneath because I wrote up above. And then we're going to go to where x is greater than equal to 1, close dot. Now, notice what happens. This time I've got rays going in opposite directions. And that makes sense because my inequality signs are going in opposite directions. And so that student who said the other one was a bus calls this an airplane. It's supposed to be the wings going in opposite directions. All right, let's go ahead and look at number 3. Can we graph that one? Well, I'm going to have to subtract 1 from both sides here to get x alone. So we got x is greater than negative 4. We're going to subtract again. All right, and we're going to get x is less than equal to negative 4. So what's going to happen when we graph that one? Well, for the first inequality, we're going to put an open dot, and we're going to the right because it says greater than. But when I graph the second one, it says x is less than or equal to negative 4. And so now my open dot's going to get closed up because of the closed dot, and we're going this way. So notice this time when I go to graph, it's the whole number line, okay? It is all real numbers, okay? Every part of the number line is closed in or shaded in. All right, now, not only are they going to give us to solve and graph some more. So once again, this is a disjunction. Disjunctions always say or. So that means we've got two inequalities to solve. So let's see what happens. We're going to subtract 1 from both sides on the first. And now I've got negative 8. We're going to divide both sides by 2 to get y alone. Okay, so we've got y is greater than negative 4 or. Now we're going to go up here and do the second one. We're going to subtract 1, and we've got negative 2y is less than negative 8. We're going to divide by negative 2. Did you hear me say negative 2? That means we're going to have to flip the inequality sign and get 4. Now we just need to graph those two inequalities on the same number line. So we're going to go to All right, so here we go. So we got negative 4, and we're going to put an open dot going to the left, and then we're going to go here to positive 4, open dot going to the right. And again, an or, a disjunction always says or, and when I go to graph it, it's going to have rays going in opposite directions. Okay, our inequality signs are going in opposite directions, or the airplane. Okay, let's look at one more. Number 8, again, this is a disjunction. It says or, so we have two inequalities to solve, and then we graph them on the same number line. All right, so since I'm doing an inequality, I'm going to go ahead and put my d's out in front. That makes sense since I have to have the letter in front to graph correctly anyway. So now we've got 5 plus d is less than 3. And then we're going to subtract 5 to the other side. We've still got to get d alone. So d is less than negative 2. And we're going to go over here and do the same thing. We're going to subtract 3d to the other side. And now I've got negative 2d plus 2 is greater than equal. We're going to subtract 2 to the other side, get rid of our floater. Negative 2d is greater than equal to negative 4. Oh, we're going to divide by negative 2, so hopefully you remember to flip your sign. Now, this one looks a little bit different. If I go here and I graph the first one, d is less than negative 2, we got an open dot going this way. And then to graph the second inequality, we need a closed dot. And did you know we had to flip the sign? So now our inequalities are going in the same direction. Our errors are going in the same direction, but remember, for disjunctions, we want all possible answers. So if you notice, this one is going to actually overtake that one, and so our answer to this inequality is going to be d is less than or equal to 2, because we want all possible answers when we're working with a disjunction. So in recap, conjunctions and disjunctions, compound inequalities.